How's it, Charmaine?
Fine and you? Morning, Greg.
Morning. Morning, morning. How's it?
Fine and you?
All good. Fine, thanks. Fine.
Andrew, you're going to record this session
I will, Charmaine, yeah.
because there are a few guys that can't attend it now. It's at work.
Okay. All right, I see we've got 5 people logged on now.
What are there? Only 5 logged on. Sorry for the delays. It still seems as though we're having some issues here, but it'll pop up in a minute. I'm trying to move the screen.
No, it's just gone blank, Craig.
Yeah, I see it's coming up slowly here. I'm trying to move the videos out of the way so that we can see the full screen. Okay, they're at the top now. Okay.
There we go, the workshop.
Yeah. All right, I'm going to leave it like that because it works better. Okay, there we go. That's what I wanted. Okay, so guys, the first thing, you can't read the top of that, but the top of that basically says the glossary. So remember that.
We can see that, right?
Okay, I just can't see it because our pictures are in the way. Our videos of ourselves are in the way.
Oh, no, I can see it fine. I'm sure everyone else can.
Okay, all right, good. Okay, so the main thing is here that as in first year, your second year, there's just some new technology that you're going to be learning, but the glossary in the beginning of this catalog of yours or syllabus is the same. And as I've said to you, if you're looking for something, you don't understand what a word means, or you need to get an explanation, this is a definition of all of the terms that you find in the notes. So always look at this glossary if you're not sure of something. Now, the first one, the benefits of having a workshop. In your first year, there was a lot of practical stuff in terms of how you do jobs. Now we're talking about what happens if you have a workshop. How can you benefit from that? And is it a good thing? I know there's quite a lot in your notes about ideas about maximizing your profitability by having a workshop. Now you can have a workshop of all kinds of sizes and complexity. I would say that you need to do naturally, you need to be able to do regripping, you need to do reshafting, but it's very important later on, especially today with the way that golf clubs are being built and designed, you need to be able to change lofts and lies. So there is an expense, and setting up a workshop that can do all of these things will take a little bit of capital outlay, and you're talking about between 50 and 60,000 Rand to set it up. And that will allow you to really maximize what you do and offer your customers a much better service. Here's a picture of a workshop where I did my training in the States at Mitchell Golf. And you'll notice that, yes, they've got all the fancy stuff. They make this equipment. It is really the top of the tree in terms of golf equipment to build clubs with. They've also got very fancy benches. You can see right in the front, this particular bench, when you switch on any of the machines, it has an automatic vacuum that sucks out all the dirt and whatever. And you can see that this workshop is carpeted. So really, by the time you finish building clubs, there's not a speck of dirt on the ground. It's unbelievable how these guys do it. But that's now the top of the tree in terms of equipment and workshop type of environment. These are two pictures of my current workshop at Cool Clubs. On the left-hand side, the picture, you're looking straight at a grip off frequency machine that you can see with the clock behind it. That is a machine that tests the frequency of golf clubs without a grip on the club. So while we're building, before we actually put the grip on, we use that machine to check the frequency or the stiffness of the shafts. You can see on the right-hand side in the foreground is the gripping station. And in the background, you'll see there's a bending machine, and I've got a workbench on the right, which you can't really see. So this particular workshop that I use is very narrow and long, but it's got all the things that you need. And the nice thing about it is that we can keep it at a really nice temperature with an air conditioner that warms it, because now that we're in winter, one of the key things about building golf clubs in winter is to make sure the environment is kept at least 20 degrees. Reason is that the epoxy that you use to glue golf clubs doesn't really bond that well in cold temperatures. It needs heat to bond. So if your club heads are starting to come off, it's not the fault of the builder so much or the epoxy, it's the environment. The weather is a bit of a problem, and we're quite cold here at the moment. Okay, so now I can't read the top of that, but I can remember what it is. It's this is now your health and safety, and your health and safety this year is COSHH, control of substances harmful to health. Now, you've obviously been exposed a lot to health and safety and PPE and all those good things. This time we're talking about the materials that you use in the workshop. So we use a lot of solvents. We try to use solvents that are less flammable, less toxic, not harmful, etc., etc. But unfortunately, we don't have access that easily to the good stuff that they use in the States, which are non-flammable and like gripping solvents. So we still, I know the practice still goes on here where guys use petrol to put grips on. Try not to do that. Try and use something less flammable with less of a lot of fuel. You don't have to have a spark or a flame anywhere. You can have it within 1.5 meters of petrol, and it can go up in flames. So you've got to be very, very careful. The symbols that you see on the bottom right-hand side are the typical symbols of a workshop that uses chemicals. So you can get onto your popular search engines and have a look and see. There are quite a lot of, there's a lot of data, in fact, and there's a lot of information online, apart from your notes, etc. However, we won't dwell too much on this. The important one here is the last one, and that is the safety data sheet. So every single thing that you use has or comes with a safety data sheet. And in your workshop, you need to keep a file with all of those safety data sheets so that if an inspector from the occupation health and safety comes in, you can show him, there's the safety data sheet. I know what happens when somebody gets this in their eyes or somebody drinks it by mistake. I know how to solve the problem. So you need to have those safety data sheets. The example in your notes is of acetone, and acetone we use in the workshop mainly for when we turn down ferrules to make the ferrules the same size as the hosel of the golf club. We then shine up that because the acetone will melt plastic quite quickly. So we use acetone quite a lot because every set that we build, we shine up the ferrule so that it looks new again. So that's the situation with health and safety in this year's notes. The next thing is the golf ball. Now, I've started with the golf ball here because your notes this year, you're going to be learning quite a lot about impact, how the club impacts the golf ball. Does it impact the golf ball straight, in other words, with no loft, like a driver? Or is there a little bit of loft, or is there a lot of loft? Now, the golf ball, we know that golf balls react very differently for different players. And it's very important for you to know and understand how golf balls will perform for different players. So a good idea would be just to test golf balls whenever you can at odd times. If somebody says to you, I really like the Z Star, or I love the new TP5X, or I love the Callaway Super Soft, you need to test it so that you understand the performance. Does it come off the club hot? How does it perform from a spin point of view? And bottom line, your entire second year is about how this contact will affect the flight of the golf ball, the spin of the golf ball, and obviously the direction of the golf ball. That's really, really important. So try and get as much information as you can and test golf balls whenever you can so that you understand what they do for various players. You had last year the ideal golf ball, so we know what the manufacturers are trying to do with a golf ball. It's got to have these particular properties. And these days, one of the important things is, as we know, the last point on this one is be appropriately priced for the golfer using it, beginner to professional. So we know that golf balls, and the way we are heading with our rand dollar situation, golf balls are very pricey. So if you can find something that performs and yet maintains a decent price, you can then offer it to your customers, and you know, they'll thank you for that for sure. So the other thing, before we go on to the impact of the club on the ball, golf balls are made, and there's tons of unbelievably good videos on YouTube, etc., of how golf balls are made, how they do it in the factories. A company like Titleist, for instance, is the one company that not only makes their golf balls themselves, they make all the equipment as well that makes the golf balls. So they don't buy anything in. Their engineers design all the equipment to produce their own golf balls. Obviously, they have to buy in the raw materials that make the ball, but their recipe and how they mix it and what they do is obviously purely a Titleist company secret. And we know that you can get close to the feel of that ball, but it's still not the same. They are essentially made from two materials, polyurethane and polybutadiene. Polybutadiene is the core of the golf ball, the middle of the ball. So the material they use is polybutadiene, and very often what they do on cheaper golf balls is they will insert some metal filings into that material on the inside of the ball, to bring up the weight, because as you know, the golf ball has to weigh a certain amount. It can't weigh more. It can weigh less than the prescribed amount. And you know those from the regulations that you had to learn last year. So they do that because they can keep the price down. So this would be your typical 2-piece ball or your 1-piece range ball. That's the type of thing. When it comes to 3-piece and 4-piece and even 5-piece golf balls, each of the layers inside the ball will do something different. The latest thing that's happened with the new range of certainly Titleist golf balls that was launched is they have gone a little bit bigger on the inside. Some of the covers. And all of that is to exhibit the correct properties. So you get, you know, the right amount of spin, the right amount of distance, all of those good things. So have a look at some online videos of how golf balls are made, and best of all, test the things yourselves. Okay, so we're looking at impact. So normal impact would be typically hit with a driver. Near normal, you're talking something like a fairway wood. And oblique would be an iron. And of course, what happens now is you start getting different spin rates. You try to get the lowest spin with the driver. You try to get the highest spin with irons. But of course, that can change depending on how that iron is manufactured. What material are they using? And you'll go through these notes. I've merely put this graph on this presentation because it's a very, very interesting graph. And what it's telling you is if you use a smooth surface, in other words, if you've got an iron that's got no grooves on it whatsoever, or it's a very old iron where the grooves have been used and used and used and they don't really have much effect. So if you look at the red line on this, that would be smooth steel, that's no grooves at all, with a soft golf ball being struck. The blue, the little triangular white triangle with the blue dotted line would be the smooth steel surface, but a golf ball that is typically what you would call, say, a hard or a 2-piece ball. And you can see how much the spin drops off just with that. But what you might find quite interesting is that even with a smooth surface striking a golf ball, you still get spin. Now, why do you get spin? There is a section in your notes and it's all about friction. So you know what friction is? If you have played snooker before or pool, when you hit a snooker ball on a snooker table, it skids along the table before it rolls. And why does it roll? Because friction takes over and it starts to create, in other words, the snooker ball sticks to the table and then it turns it into roll. So that's friction. That's why we can still hit a golf ball with a smooth surface and get some spin. Just to touch on last year's little notes regarding aerodynamics, etc., just remember that the dimples on the golf ball don't necessarily create spin. The loft of the golf club gets the ball up into the air. The swing style, in other words, negative attack angle with an iron will compress the golf ball the golf ball climbs up the face, the grooves create a bit of spin, and the dimples hold the golf ball or keep the golf ball in the air. So it's really the type, this graph is showing the type of golf ball and what kind of spin will you get. So if you look at the grooved steel with a soft golf ball, which is the blue line, that you will get the most spin with a new grooved golf club with a tour quality or premium quality golf ball. A polyurethane cover or a urethane cover, as opposed to the other name that you might have come across for the cover of golf balls is called Surlyn, S-U-R-L-Y-N. Surlyn is a artificial plastic which is very, very durable, so you can hit this golf ball a lot of times before it starts to scuff. But of course, that is going to give you something like the red dotted line. So if you look at the little red squares with the dotted line, very similar to the blue triangles with the dotted line, those are both hard golf balls. And the difference between those two is very simply a grooved club face and a smooth club face. Not much difference, as you can see. But yes, you do get a little bit more spin. So this graph really just identifies how much spin you can get. And at the very bottom, along the bottom axis of this graph, is the degree, all right, the degree of loft. So you'll see there that the blue line, 60 degrees, and that's quite an important number. That you'll see that the spin goes up when the loft of the club is 60 degrees, so your typical lob wedge. However, the minute you go above 60 degrees, so if you go and buy yourself one of these 62 or 64 or 68 degree wedges, you ain't going to get any more spin. You are going to get some height, but you'll see how quickly the spin drops off as that loft goes up. And that's a key kind of fact in this whole impact and spin story. So here is another graph where clubs have been, golf balls have been hit using a robot hitting the golf ball. So you get exactly the same impact, the same speed, the same everything. Again, with these different golf balls, the hard one, the soft one, etc., etc. And you'll see that how the spin goes up if you look at the blue line there. And this also gives you a very good indication. If you're doing fittings, eventually you get into fittings and somebody says, typically with their 6-iron or 7-iron, how much spin should they get? It usually works very close to a 5-iron is 5,000, a 6-iron is 6,000, a 7-iron is 7,000, an 8-iron is 8,000, in that region. But it does depend on how they strike the ball, and you're not going to get that exactly to those numbers, but it gives you an indication. Some of the guys, like the tour players, on the men's tour, their average 6-iron spin is 6,200 RPM with a 6-iron, and the ladies is somewhere around about 5.8, somewhere in that range. Again, this graph is really telling you how this drops off when you're using a different type of golf ball. And you'll see that the black line, you'll see that after an 8-iron loft, which typically these days is about 36 degrees, you'll see how quickly that drops off in terms of spin. And what does that ultimately do? The ball doesn't stop on the green. So that's why it's important to choose the right golf ball for the player's swing type and the clubs that they are using. Also, most golfers want to hit the ball further. Doesn't matter what club they're using. They would rather tell their mate that they used a 7-iron to hit their second shot instead of a 5-iron. But I mean, that's not the ultimate situation. Where did it finish is most important. It's fine to use the 7-iron, but did you get it on the front of the green, or did you get it in the middle of the green near the flag? So, you know, as long as you understand how spin works using different types of surfaces. The other thing that comes up here is there's a section in your notes called flyers. So what is a flyer? You've all heard the term, I think. Now it's it's in winter time here. You get into the rough. The grass is not very thick, but it is nevertheless quite long. So you're going to get grass between the face and the golf ball. You have got no idea how far you're going to hit it. You can judge the distance and take the club pertinent for that distance. But when you strike it, the amount of grass between the face and the ball will affect the spin huge, amazing. For instance, when you do fittings, we use face tape on the face of the club to indicate club length. Where is the impact on the face? When a person hits the ball with that face tape on the iron, from usually getting 5,600 or 6,000 RPM of spin, with that face tape on, it's never more than about 3,000 or 3.5. So that gives you an indication of when you're playing out of the rough, what happens. The lower the spin, the further the ball goes. And it goes further because it doesn't stop. Obviously, there's no spin or very little spin. So that's a section you need to really concentrate and have a look at how the club performs based on where the person is playing it from and how their swing, in terms of the dynamics of their swing, creates the impact. That does change a lot. So here's the important one that I mentioned, that spin increases with club head speed. That's the first thing. It increases with loft, but only up to a specific angle. And they're calling it, say, a max. We know that it's around about 60 degrees. Then spin rapidly falls off as the loft angles increase above that. As long as the loft angle is less than 60, say, in this case, spin imparted with different combinations of ball type, groove configurations, wet or dry, doesn't vary very much. Now, that kind of is a little bit contrary to what we've been talking about. But what they're saying here is that it's really important, the difference between all of these ball types, grooved faces, is that value of a max. So if you've got, you don't use a 60 degree, you only use a 56 degree wedge, for instance, you can expect to get or to maintain a little bit more spin, because over that 60, the spin's going to drop off. So it's an area where, again, you can test. You can go and hit some shots with very lofted clubs and just check what happens. You obviously, many of you have already tested this and you play your shots in a different way to create spin. You just need to understand the dynamics of this. Okay, the next section we're talking about is the golf club itself, design, style, etc., and how these things are made and with what materials. So typically your categories of an iron are blades and cavity backs and variations of those. So your Titleist CB on the right-hand side here, even though you would possibly call this a muscle back, it is actually, if you look at it carefully, is a cavity back. It has material cut away from the back of the club, but it's got a nice meaty sort of pad at the back of it. And this particular iron, as it happens, is a player's club that performs exceptionally well in terms of shaping the golf ball and all of those good things. But it can appeal to a much wider range of golfers. In other words, a higher handicap player can use this club very, very effectively. So let's just talk about blades. First of all, your typical blade, or let me call it more of a, when we say blades, we're not just talking about your flat bladed club like the MB on the left-hand side. We are also talking about a forged golf club. You'll see the word forged stamped on the back of these. Now, some of the golf clubs will have the word forged stamped on them, but it doesn't mean that that golf club is fully forged. Now, what is forging? So the difference between forging and casting, these are the two methods that golf clubs are made from. So a forging is made using a material called carbon steel. Carbon steel is a soft metal that starts off with a little tube, if you like, a little tube, maybe a little larger than the size of the hosel of this golf club on the left-hand side. If you look from the face or the top of the line of the golf club face to the bottom of the hosel in the picture here, that amount of metal, or a little larger than that, is the type of billet of steel they would use to forge a golf club head like that. They simply put that billet of steel into a pattern that is shaped like this head, and they slam it down with a 30-ton press a couple of times until it comes out looking something like the shape of this head. It's then finished off pretty much by hand, using grinding or belts on grinding machines, and it's finished off, and then it's finally chrome plated. So these particular finishes you see on these clubs here are chrome plated. It can be bright or it can be dull, but it's nevertheless got nickel chrome plating on it. When it comes to your typical cavity back club, I'm not talking about the forged one on the right. I'm talking about your Callaway Maverick irons. I'm talking about your TaylorMade Sim irons, these sorts of things. I'm even talking about your Titleist T300s, T200s. Those are cast golf clubs. So they are made from stainless steel, not carbon steel. Stainless steel can be, it's a mixture. You can have this stainless steel blended with different materials of stainless steel to give it different properties. Common ones that are used in the better quality of golf club, very durable, takes a lot to destroy these clubs, but you usually see the terminology. If you look at specs of golf clubs, it'll say 304 stainless steel or 430 stainless steel. Now, what that allows you to do, it allows you to bend the hosel so that if you need to do any loft and lie changes, it's not difficult. With some of the old clubs, like the very first Ping golf clubs, and Ping were the guys who created the casting process for golf clubs anyway. Casting is a very, very old process. It's not new, and it's not pertinent to golf clubs. But the casting process is simply they melt the metal, they pour it into a mold of the shape of the club. And in fact, it starts out, first of all, where they make the mold out of wax. They make exactly the shape of the head. They make it out of wax, and then they dip that wax mold into ceramic powder. They make it until that mold now dries and it becomes hard. Ceramic is a material that has a higher melting point than the steel. So they would then pour the molten steel into that mold, and they would then break off. What happens when they pour that in, the wax actually comes out, and they still have the shape of the golf club from the ceramic mold. The wax pours out, and ultimately they break off the ceramic, and you are left with a stainless steel head that looks exactly like the mold that it was made from. So that is a casting process, and they can duplicate that many times to produce exactly the same looking head. So that casting process was invented and developed for golf clubs by Ping, but in those days they used 17-4 stainless steel, and you still see it today a lot with some of the cheaper castings are made from 17-4. Why? Because it's very cheap and it's very durable. But it's a hell of a thing to try and bend those clubs if you want to change the lie angles. So that's the two processes. Don't get that confused. Forging is carbon steel hit with a press and finished by hand and chrome plated. Cast golf clubs, molten steel is poured into a mold, and then the club is polished. And of course, with stainless steel, it's not plated. The stainless steel doesn't rust. And if you hit a stone in the rough and you've got to grind that away, you can do that and polish up the club again, and you've got a perfectly good golf club. Okay, hybrids, fairways, and drivers. What are they made from? So you've heard that titanium came into the golf industry in the late 90s, mid 90s, and golf club heads were starting to be made from titanium. Before that, metal drivers were made from stainless steel, and they were very small. The metal-headed driver, the first ones, was obviously the tailor-made guys. They were called Pittsburgh Persimmon. Persimmon was a wood that golf clubs were made from in the old days, drivers. And persimmon is a very, very nice wood that gave you very good feel when you hit the golf ball. So when they made the first metal wood, they called it Pittsburgh Persimmon, because Pittsburgh in America is where all the metal is made, or a lot of the steel is made. So they called that first tailor-made driver the Pittsburgh Persimmon, and it was made of stainless steel, and it was about the size of just a little bigger than your hybrid these days. So what we have today, hybrids, fairways, and drivers are usually 90% of the drivers, or 100% of the drivers these days, are made from one or two different grades of aircraft titanium. Very, very hard material, very, very incredibly durable. And a driver head is made in three parts: the face, the crown, and the sole, all welded together chemically. And they can position the weighting inside the head in different places for that driver to perform differently. The fairway wood is usually made from stainless steel these days. It hasn't changed. You can get titanium ones, but generally most of them are made from stainless, as are the hybrids. You'll notice here some of the designs. On the left-hand side, you've got a bottom weight in the hybrid here, forward of the rear of that. So the weight is towards the front of the club, and that usually lowers the launch. With the TS3 in the middle, the fairway wood, you see, there is a little cylindrical weight which is screwed in from the top of that head, and it allows you to change the position of that weight to the toe or the heel to give you a different shape, draw, or fade. The one on the right-hand side is the driver, which has a back weight, and that will allow you to lift the ball up in the air. The further the weight is back, the higher the launch will be. So obviously in the Titleist range specifically, they've actually got 4 drivers. They've got a TS1, 2, 3, and 4, with 4 being the small tour head, very difficult to hit for the average golfer, but for high swing speed players, very good performers. This range of drivers, fairways, and hybrids obviously is of the highest quality and unbelievably good performance as well. Then we go on to the irons, and we're talking here about center of gravity, and when you strike the ball out of what we call the sweet spot, what happens. So you'll see in the middle, the sweet spot on a golf club is literally a spot. Okay, it's the size of a pinhead, the absolute sweet spot of a golf club. So when they talk about widening the sweet spot because of a perimeter weighting situation, what they're really meaning is that they're increasing the moment of inertia, which we'll talk about in a second. What that means really is that when you strike the golf ball somewhere outside of the middle of the face, you don't lose a lot of speed in terms of ball speed. Remember, the most important thing when you're doing, you're checking data from players striking golf balls, it's ball speed that counts. It's not club head speed that counts. So you want to try and hit this as centrally as you can to get the most ball speed. I won't dwell too much on this because I want you to investigate this in your notes, and any questions you can obviously ask through the line or send me mails or anything you like, and we can discuss it if you're not sure about something here. But we're going to move on a little bit quicker here because this, I know that we started late, so I'm going to move it. I will go until about 8:15, 9:15, if that suits you guys, because otherwise we won't cover what I need to cover. At the bottom here, we're talking about offset and onset. So this is incorrect if you have a look at it. When we did the changes in the catalog, we gave this to somebody to do, and unfortunately they made a few mistakes. So the pictures that you see on this slide were in the notes. I don't know if your notes, so you can check this in your notes. Just make sure that you reverse those 2 labels at the bottom there. The onset golf club is on the left. And what that means is the leading edge of the golf club is in front of the hosel line. Okay? The one on the right-hand side is an offset golf club, where the leading edge is behind the hosel line. And what happens with the offset golf club, the one on the right-hand side, a lot of the and stop that slice or fade from a beginner golfer or a new golfer. The one on the left-hand side, which is your onset club, quite a lot of wedges are made with an onset, which allows you to nip the leading edge under the ball quickly, and also in a fashion it can prevent the dreaded shank. Okay, let's talk about face plane tilt, loft and lie is the section here. Club that you see at the top of your screen is a golf club positioned correctly. Okay, so that is how you would like to strike the golf ball at impact, dynamically. That is what the club should look like. The arrows that you see is how you measure the lie angle of the club. I've tilted the picture on the left at the bottom with the toe up in the air, okay? I drew a line, you may be able to see it. It's a very thin line, but you'll see that the toe is sticking up a centimeter or so off the ground. Now, this is where a lot of you will get confused. I promise you, and you'll battle to get this, but the one on the left, if I could ask the question, I would ask it, but I will rather tell you. The one on the left means that the club is too upright for the player. So the quick way to understand and to remember that is too upright, toe up. Now that is when the player is holding the club in its playing position. That particular club for that particular player is too upright for that player. It may not be too upright for everybody, but for that player holding it like that, it's too upright. The one on the right-hand side is too flat for the player. So that if the lie angle has been bent flat and he then holds the club in its hitting position, the toe is presented to the ground. What happens with this is let me just have a look if I put it in here. No, let's go up again. So the one on the right-hand side, when you've got a club that's too flat like this, the ball will move to the right. When the toe is up on the left, the ball will move to the left. And that is because the angle, if we look at the next one over here, you can see the loft in the picture on the right. That is how loft is measured. But now if you tilt the club so that the toe is up in the air, that loft, well, for a start, because the toe is up in the air, it's going to point that face to the left. You can test it, you can try it, and you can see. But this is how loft is measured, from a vertical line back to the face of the club. Now, on the left-hand side, the club, these are typical traditional lofts and lies of golf clubs. And if we just look at, say, a 6-iron, you'll see that a 6-iron length of golf club, 37.5 inches long. The lie angle is typically 61.5 degrees, and the loft is typically 30 degrees. This is what we would call traditional lofts. They are not like that anymore, excepting in tour players' clubs. So your typical MB blade that I showed you would be a 30-degree loft, or maybe 29. But if you're looking at your Sim Max irons these days, you're looking at your 6-iron being closer to 26 degrees. So can you see that the modern golf clubs, they've moved the lofts very much stronger, almost 1 to 1.5 clubs stronger. But it's not only, they're not trying to fool you too much. What they're trying to do is equalize the loft for the design of the golf club. So many of these golf clubs have got a lot of low center of gravity, and that will get the ball up very high and very quick. Therefore, they need to lower that loft so that you get the right distance gappings. And that's where we go to next. You want to have on the left-hand side a typical 10-meter or 12-yard gap between your clubs. So your 5-iron, if it was 27 degrees, you would want your 6-iron to be 31 degrees, your 7 35, and your 8 39, giving you typical consistent gapping. And why that's important is because when you get to wedges, the modern wedges these days, some of them are 44 degrees. So you need, literally, you need a 48 or 49 degree gap wedge. And as you know, some of you, that Titleist make in their T300s, T200s, etc., they include a 48 degree, which they call, they've got a pitching wedge, and then they've got a gap wedge as part of the set, just because the lofts have got so strong. if your lofts, and very often we check every golf club when it comes back, especially forged golf clubs from the factory or when they're new, very important to check your lofts and lies when they're brand new. Reason, factories don't always get it 100% correct. So if your 5-iron, which should be 27 degrees, is actually 26 degrees, and your 6-iron, which should be 31 degrees, is actually 32 degrees, you've now got a 6-degree gap, which will give you 18 yards of difference between those two clubs. And then your 7-iron being 34 degrees instead of 35, the difference between that is only 2 degrees between the 6 and 7-iron. So you'll only get 6 yards gapping difference. So this is really, really, really important for you to understand the difference, that the gapping has got to be consistent. This section is an important one, which is called gear effect. And the pictures here on the bottom right-hand side show you how gears work. So as the one turns anti-clockwise, the other one will turn clockwise. Why is that? Because the face of a driver is bulged, or it's from toe to heel has got a bulge, and from the top to the bottom of the head of the club, there is roll. So the face of the driver is not flat, and it will create this gear effect. If you hit the ball from the toe or the heel, the ball will spin the other way. And that's why they built like that, so that you can equalize and get the shot moving towards, or not staying out right. If you hit an iron shot from the toe of the club, the toe moves into an open position and the ball will go to the right. You've all experienced it at some point in your life, and that's the way that it works. So gear effect is, in fact, very important. Drivers, fairways, hybrids are usually made with that bulge and roll on the face, which helps you to hit the ball straight when you hit it off the toe or the heel. The next thing we're talking about is matching of golf clubs. So we can match golf clubs in two different ways. We can match it with swing weight, and I've shown a picture of a swing weight scale there, and then moments of inertia matching. So let's talk about that quickly. Swing weight is the most popular and has been around forever. So swing weight is really, how does the club feel when you're swinging it? Does the head feel heavy, or can you not feel the head? This is a lot of practical application, swinging different clubs. And it's amazing that when I do fittings and we change heads of irons, the guy will have one club and he'll swing it and hit shots. I'll put another head on and he'll say straight away, wow, this feels much heavier. Meanwhile, it's lighter. But it's not the case of it. It's actually the shaft is stiffer. That's really what he's feeling. But the factors that you need to know with swing weight is that the length of the club affects swing weight. So for every half an inch longer the club is, it's 3 swing weight points heavier. So instead of D1, it's D4. The head weight of the club will obviously make a difference. So for drivers that are usually 190 grams in weight, if you use a tour weighted driver, which is 200 or 205 grams, it's going to make the swing weight heavier. The weight of the grip will now counterbalance that, and you'll get an overall weight increase, but you'll get a swing weight lightening effect, maybe half a point or 1 point, just depends. And then the weight of the shaft is a factor. So from your graphite shaft of 70 grams to your steel shaft of 120 grams, you're getting 4 or 5 swing weight points difference just because of the weight of the shaft. So that's really important. And then the balance point of the shaft is important too. Very popular this year is that a lot of the premium shaft manufacturers in drivers are bringing out counterbalance shafts so that the grip end of the shaft is heavier than the tip end. What is that? Why is that important? Because it allows you to swing the head quicker. And in some cases, if they make that shaft stiff enough at the tip, you still maintain consistency. So the balance point is really important these days, and it's become a big thing. I'm getting the first batch of these new shafts in next week, so I'll do some testing and then I'll understand and maybe can pass on some info to you later. Moment of inertia matching. So this is something that was devised mainly by Tom Wishon, famous club fitter in the States. And Tom uses this particular method of matching. I'm a fan of it. I've built sets like this. It's a huge mission to build sets like this correctly, because what you do is you try and get that number that you see from this moment of inertia machine. You try and get consistency through these numbers, and you've got to add weight into the butt end of the club, and honestly, it takes you forever to build a set of clubs. And I did one for myself out of pure interest, and the feel was horrible. So it's not something that I do. There is a company in Cape Town called Golf Science that build their clubs like this. I'm not a fan of it personally. However, you need to know that it's a method of matching golf clubs that's very important. Here, a frequency chart showing you what happens when you've got two sets of irons that are built differently. One thing you need to understand is that golf club heads in irons, from the 4-iron, 5-iron, 6-iron, 7-iron, the weight of the head of the iron is 7 grams heavier as the number increases. So if you've got a 4-iron at 250 grams in weight, the 5-iron will be 257, the 6-iron will be 264, and so on. So as the iron head number increases, the weight of that head increases by 7 grams, because the shafts get half an inch shorter per club as the club gets shorter. So to balance that, the head weights need to be 7 grams heavier, but then the stiffness or the frequency of these shafts need to also be in a straight line, as it were. And you'll see these blue diamonds on your screen, on the screen here, from the 2-iron, 3-iron, 4-iron, 5-iron. The numbers on the left is how we measure frequency. It's called cycles per minute. And in this case, if we look at the 6-iron, move across to the left, you'll see it says it's almost 300 cycles per minute. Now, I know that that particular would be your typical stiff flex golf club. So it goes up, and it needs to be the same frequency, those frequency numbers, as the club gets shorter, from 6 to 7 per minute, increase by 4 to 5 cycles per minute per shaft. Don't worry too much about that. It's just a method of, you've heard of, is that a frequency matched set of golf clubs? That's how we match frequency, by getting all of the stiffness of the flex of the shafts to be in a straight line. The blocks that you see below that are all over the place, is a graphite shafted set that hasn't been frequency matched. And you'll see that the 6-iron and the 7-iron, the 7-iron will be much softer in flex than the 6-iron. So this is why somebody will say, I can hit everything in my bag except my 7-iron. There's something wrong with the 7-iron. And very often it'll be a case that the shaft is too soft, or it just doesn't match. So that is frequency matching, and that's how frequency is done. So that kind of finishes the syllabus, I would say. And I think that if you have questions, it's going to be much easier for me to answer them via WhatsApp or online. Send me mails. You can send it to my email address. I think you've all got it, golfpro.greg@gmail.com, and or via the PGA. Anything you don't understand in the notes, let's revisit it, and I will answer questions anytime online. So